Hello everyone. Welcome to this installation of our Inside xtUML learning series focusing on safety critical applications and the xtUML methodology. Interest in adopting modeling is increasing in domains requiring safety critical design practices. In this presentation, we'll explore the benefits of the xtUML methodology alongside the capabilities of BridgePoint and ReqTracer, two products from Mentor Graphics, which when combined can help implement a requirements-driven xtUML process that satisfies the requirements, validation and verification, and code quality needs of the safety-critical design community. Before I begin, I'd like to thank the xtUML.org community for organizing this series and for providing the opportunity to share with you some of my knowledge of safety-critical design and the xtUML methodology. If you're unfamiliar with xtUML.org, I'd encourage you to type that URL into your web browser, and once you land at the site and start to explore the site, what you'll see is a community of like-minded members that are actively working with xtUML and willing to share their experiences with you. As a community member, you can benefit from the ongoing projects to develop models and tools that support this xtUML approach. And there's a growing list of these projects, and the entire community benefits when you're able to contribute to these efforts. As part of the community's efforts to broaden the tribal knowledge of xtUML, we created a series of seminars called Inside xtUML, a learning series. These seminars are prepared and presented by community members to share their knowledge and experience with others. So I want to thank you for joining me, and I encourage you to visit the xtUML channel on YouTube to view recordings of earlier presentations by other members of the community. So the agenda for today's presentation is as follows. So first, I'll do a short introduction discussing the challenges of systems design today and how certification challenges add to the complexity of these development processes. Then I'll give a very brief overview of model-driven development and the xtUML methodology, though I certainly encourage you to review the modules that have covered these topics in much more detail in earlier sessions. And next, I'll explore how an xtUML approach can facilitate a highly productive design process with certification requirements. We'll then take a brief look at a user experience from the company Saab, and then we'll wrap it up. So let's get started. If you're involved in systems design, I'm sure you're fully aware of the complexities of designing these sorts of systems. Design requirements are becoming more complex in all domains, but especially in Malero and automotive. Reductions in SWaP, or size, weight, and power, are critical, and these, of course, are tied tightly to reductions in cost. The market continues to push hard on new features and higher performance, but in these domains, reliability and safety are also especially crucial. Today's more electric systems really are a convergence of multiple disciplines, and all of the pieces have to work together. This includes digital design, analog design, software, and the mechanical elements. This requires communication and cooperation among very diverse teams, and in fact teams that may actually be dispersed across the supply chain and possibly in many different regions around the globe. This is very challenging in and of itself, and is compounded by the complexities of using different tools with different languages, different file formats, and so on. And finally, it's not enough to get a design out the door. The design should really be the optimal design. If your company doesn't design it, some other company will. And that means they did a better job of optimizing reliability, performance, manufacturing cost, and overall lifecycle cost. Really, the company that masters this sort of design optimization is the company that really will own the market. So systems design is challenging enough, but in those domains with mission and safety critical requirements, this can make things even more complex. Let's take a look at the certification challenges. Certification of complex systems involves development assurance. The idea here is that no system will be free of bugs, but one that follows a process that enforces design or development assurance dramatically reduces the chances of producing a design that has errors that affect the design's safe operation. So in these sorts of programs, quality, the term quality, means that the product meets its requirements or performs its intended function with no unintended functions. This is assured in these sorts of programs through a structured and controlled development process, which focuses on the importance of requirements. It also involves documentation of the process itself along with the end product, and this really lays the foundation for a third goal in these flows, which is repeatability, a development process that delivers deterministic, repeatable results is really preferred over an ad hoc, non-deterministic approach to design. Another important aspect of these flows, which is pertinent to our discussion today, is tool use and mitigating associated tool risks. So let's take a look at all of this a little bit more deeply. When something goes wrong in a program, more often than not it had something to do with requirements. And this is quite understandable because each new generation of design seems to have an increasing number of new requirements that are constantly evolving throughout the project. And as such, this whole issue of requirements and dealing with requirements can be really difficult to manage. Development assurance processes really focus on requirements and include the key tasks of 1. Capturing requirements in a form that can be shared, and this is typically in a document written in a natural language such as English. 2nd, validating requirement intent, because there really can be a variety of interpretations of meaning when something is captured in a natural language. 3rd, tracing requirements from description to implementation and verification in the design. And 4, finally, verifying that the implementation meets its requirements. Now, I'm not sure if you can read the little cartoon here on the right, but this is just a funny little way of demonstrating the importance of capturing, understanding, and implementing and verifying requirements across teams. So here the guy on the left says, "I distinctly said monorails," while the guy on the right says, "did not." Now, while this makes light of the issue, this sort of misunderstanding happens all too often in complex programs, and it's certainly one of the primary reasons that programs can fail. And these sorts of things often aren't discovered until well into the process. I mentioned this already, but it's worth repeating. The goal of safety and mission critical programs is to ensure that the end product or system meets its requirements, meaning it performs its intended function without any unintended behavior. Ensuring this is really the job of a structured development process, which must be planned and documented. These development processes depend heavily on the proper management of requirements, as I described in the last slide. And in terms of requirements verification, the idea is to verify early, verify often, and verify the implementation in the context of system requirements. And if you can do that early and often, all the better. So I'm highlighting this here because this is an area where an xtUML process can really help with these objectives. And I'll be covering this in a little bit more detail later in this presentation. I mentioned documentation already. This is really an important part of the process, though it certainly can feel overwhelming. Safety and mission critical programs can involve massive amounts of paperwork, starting with planning documents, then documenting the process, then documenting the design itself. So plans are captured, any deviations from the plans are captured, and even more important, all pertinent information about the design itself is captured. Now this last bit here that I've highlighted, this is really where an xtUML process can help. A development process that delivers deterministic, repeatable results is preferred over an ad hoc, non-deterministic approach. This is really almost a side effect of a structured, documented development process. In other words, if you define and document a structured process, it should, for the most part, be repeatable. But add to this automation, and this can really support the notion of repeatability. And again, I highlight this because an xtUML process can really help with this aspect of a certification program. Mitigating tool risk is a big concern in these flows as well. So when tools automate tasks that would otherwise be done by manual methods, risks from tools must be examined. And this is really no different than reviewing manual work in a project. If a person writes some code, that code has to be reviewed and verified. So tool results need similar treatment. Now, a lot of folks refer to this process as tool qualification, though the specific terminology can certainly vary by which standard you're talking about, as you can see here. For example, in DO 178B or C, which is sort of one of the more foundational software standards, they call it tool qualification. In DO 254, the process is called tool assessment, and it might lead to tool qualification. In ISO 26262, the new automotive standard, it's called confidence in the use of software tools. So even these different standards, even though they have different names for what they're doing, there's some similarities in what each of them are requiring. There's three main things really. First, examining the criticality level of the design itself. So how safety critical is the end product that you're producing. The second is understanding the risk impact of the tool usage on the end product. You know, how big of a risk does the tool pose given how you're using it in the development process. And the third one is kind of looking at what sort of mitigations are employed in the design process itself, you know, that can eliminate unacceptable tool risk. I'll come back to those certification challenges in a little bit, but right now let's step back and briefly examine what we mean by model-driven development on how an xtUML process supports such a method. Now I'm going to cover just enough to give you a very high overview of all this. For those of you who need a little bit more, I'd strongly encourage you to watch the first few xtUML Learning Series episodes to get a better foundational understanding if this is your first exposure. The terminology surrounding flows with the word model in them can be a little confusing. And mostly this is because people tend to kind of use these terms somewhat interchangeably. But for my purposes in this presentation, I'd like to clarify what we mean by these terms. So first, let's start with model-driven engineering. This generally means the use of models in support of an engineering process. So most engineering processes do make use of models in some way or another. So this is sort of the largest scope. Within that scope, there's also model-based design or model-based engineering. This typically means that the engineering process starts with a high-level model to describe the system concept. Unfortunately, in all too many cases, that's where the use of the model ends. It simply sits on a shelf and is possibly never referred to again. So this leads us to model-driven development, and I'd like to explain why that is a bit different. Model-driven development is part of a model-based approach, but instead of shelving the model at the conceptual stage, the model itself becomes a vital and evolving part of the downstream development process. In fact, the model isn't separate from the design, it actually is the design, and it grows and evolves throughout the process. An important aspect of this is that there's a flow from one level of abstraction to the next, down through the actual implementation, which is directly derived from the initial model. An xtUML methodology directly supports a model-driven methodology. This picture is a little complex, so let me walk through it. The boxes in the middle represent the models, the xtUML models. These start out at the conceptual level, fed by high-level design requirements. This conceptual model is a mechanism to validate requirements. As even at this high level, the conceptual model can be executed, which serves to demonstrate the requirements and validate along with communicating the intent of the proposed product. Once the high-level requirements are validated and understood, the conceptual model can be modified to explore various architectural alternatives. And here I'm calling these solutions model. So each solution can be explored. They can actually be executed to examine various criteria, and this leads to the choice of an optimal solution. This optimal solution becomes the system model, which defines the components or subsystems of the model and the interfaces between them. This too is executable, and not only becomes an executable specification for the downstream development of each of these subsystems, but can at the same time include test bench models that can be used at any time as a virtual system test structure for the subsystems and their respective pieces. The subsystem developers can then take the components of the system model that represent their subsystem and continue to refine their implementation in xtUML format, adding more detail but still keeping the design as a platform-independent model for maximum reuse potential. They add and track derived requirements from their design choices, and as they design, they can frequently test their refined models in the system context via the test environment. They can also demonstrate or document their design at any time. And finally, the last stage is implementing the actual target model. And in many cases, this can be generated automatically from the platform-independent model to the actual target implementation. So that was your whirlwind tour of an xtUML methodology. Now let's look at how that xtUML flow I just talked about supports the needs of a highly productive, certification-focused development process. In an earlier section, I talked about certification challenges and made some comments about areas that an xtUML methodology can help with. So now we're going to look at each of these areas in more detail, highlighting how this xtUML methodology can facilitate these certification objectives. xtUML and requirements validation. Now first, let's clarify what we mean by requirements validation. This often gets confused with verification. And it's even more confusing because sometimes these two things are lumped into what people call V&V, or validation and verification. So validation of requirements is the process of ensuring that the captured requirements are really the right requirements, that they capture what it is you really want the product to be or to do. Now, some people say it's ensuring that you have the right product description, or more simply answering the question, are we going to build the right thing? So, how do you validate requirements? It's typically done today via manual review of a natural language description of requirements captured in a document or in a database. So each requirement is reviewed against a set of criteria. Things like, is the requirement correct? Is it complete? Is it consistent with other requirements? Is it unambiguous? Can it be verified? And so on. There's a set of criteria. And what you have is a bunch of people sitting around a room, kind of debating all of this. So as opposed to this idea of getting a bunch of people in a room, sitting around and speculating and debating about all this, there's a better way. So developing a conceptual model from the requirements and being able to execute this model to demonstrate the behavior at this initial step of design is a much more powerful approach. I touched on this briefly when I went over the xtUML flow earlier, but this is a really powerful capability. And as a first step in the design process, an xtUML model can be built that not only implements, but links directly to the system requirements. And we'll talk more about that in the next few slides. And this model can be run to demonstrate the behavior that these requirements provide. This can be demonstrated, debated, and modified as necessary during an enhanced requirements validation phase of design. So this xtUML model really becomes the embodiment of requirements. I've been asked about this before, with some people thinking that maybe the model somehow replaces requirements and captures them directly. And I think that we'll probably get there someday, but I'd not recommend taking that leap just yet. The technology supports it, but I'm not sure the certification community is quite willing to accept that. So I still think there's a place for captured requirements that can be examined independent of the model, and that instead you simply trace from that document or that database into the requirements implementation within the model. So companies establish requirements traceability in a number of different ways. This can be as simple as internally maintaining a spreadsheet, or as complex as utilizing some serious features of a PLM type requirements management system. And really I've seen everything in between. In fact, we here at Mentor have several different ways that we can provide this sort of capability with our tools, but in this case I'm going to show you how it can be done with two tools, ReqTracer for requirements tracing and management, and the BridgePoint xtUML suite, which is, I've mentioned BridgePoint before. BridgePoint is really our comprehensive xtUML offering that supports the flow that we're talking about here when I talk about the xtUML methodology. So let me give you a brief introduction to ReqTracer. So ReqTracer is not a requirements capture system. Requirements are typically captured in an enterprise level database such as DOORS, or in Office documents like Word or Excel. And which method is chosen really probably depends on the size of the company or the flexibility that the company offers. Or sometimes the level of design. At system level, sometimes those requirements are captured in the enterprise level database, and at the lower, like hardware or software level, the requirements might be stored in just simply documents. So ReqTracer doesn't capture the requirements, and ReqTracer is also not a design tool. So Mentor and other EDA companies offer lots of tools that are used in the design and verification of systems and their implementation. And in fact, our BridgePoint xtUML suite is one of those tools. But what ReqTracer really does is connect the requirements sources to the requirements implementation, and tracks all of the pertinent data that's necessary for tracing and management of requirements within a design project. It connects both to design implementations done inside the tools, as well as the verification results that come out of the tools. And from this, it can provide a number of really useful reports, including those necessary for both project management and certification audits and compliance. So this is a simple screenshot of ReqTracer. This is the GUI. And you can see in this project, really simple project, it has two data sources. A Word document containing requirements for the GPS watch that you might recognize from earlier xtUML series sessions, and also the xtUML model for this watch, which is created in BridgePoint. So let's take a look here at the Word document in a little bit more detail. So ReqTracer works off of requirements tags, and once the correct format is specified, it picks up these tags from all sources and makes the appropriate connections. So here we're showing the requirements tag in the Word document connecting to the property in the xtUML model. So ReqTracer makes these connections between the tags and then provides an easy-to-use interface that lets you navigate the requirements through their implementation and verification within the models. It isn't shown here, but you could just as easily connect the requirement to the appropriate test and track test results through the process as well. So again, this is one way that an xtUML methodology can satisfy the requirement tracing mandates of these safety critical flows. Now, what about documentation? If you ever want to see an engineer shudder, just start talking about documentation requirements. No one, especially engineers, really likes to write stuff down, and the requirements of documentation for certification can be overwhelming. Another issue with documentation, besides its abundance, is that as soon as something is written down, it can quickly go out of date. So, I'm not going to lie to you and tell you that an xtUML methodology can take care of all your project's documentation needs. That's a bit of a stretch. You still need to write all of your plans and follow them, but in terms of documenting the design itself, this is something that an xtUML flow can assist with. Our BridgePoint xtUML suite offers a feature called DocGen that creates HTML documentation covering both the state and progress of any model or piece of model. So this basically documents a snapshot of the design anytime you want to take that snapshot. And this is great not only for internal reviews during the development process, but also in automatically generating the documentation of the design descriptions required for certification compliance. Thorough requirements verification is a key theme of any safety critical flow. Earlier we talked about the confusion between validation and verification. We said validation was determining if you were going to build the right thing, which required a review of requirements. So verification is ensuring that you are building the thing right. In other words, it ensures that the requirements that earlier during validation had been deemed to be the right set of requirements have been implemented properly in the design. The xtUML methodology supports enhanced verification that nicely aligns with the goals of safety critical programs. For example, in support of the test early and test often objective, an xtUML test bench component can be built in parallel with application components. This enables same-day design and testing. These tests can also be used at various levels of abstraction and throughout the design flow. The tests themselves can also be automatically converted through the various levels of abstraction, from xtUML to a target language, just as the design models are. And in support of system test, the initial system-level test bench can be used as a virtual integration platform in which to integrate implemented components back into the system testing environment for early and ongoing virtual system integration and testing. This, by the way, is not only supportive of certification goals, but can really provide a huge productivity gain as well, catching critical integration issues at early stages of design where they can easily be remedied, as opposed to the typical late-stage integration testing where issues found could be crippling to the program. Repeatability is another key element of a structured and controlled development process, and it's important for a variety of reasons. First, certification programs require documentation of a process that is assumed to be repeatable to reproduce identical items. If there's any sort of investigation about a design and the process by which it was created, it's essential to be able to recreate the steps to recreate the design. So a documented repeated process is a certification requirement. It's useful also in a more practical sense. Designs may need to be recreated on new platforms as technology becomes obsolete. For example, a 50-year aircraft life cycle is orders of magnitude longer than any of the life cycle of the technology that it's built on. So the more repeatability that there is in the process, the less rework is required to re-implement the design. So in this case, repeatability and reuse go hand in hand, and it becomes very easy to create a new platform dependent implementation from a platform independent model. The normal process of code development from specs, the normal process, like manual process, can have almost an infinite variety of implementations, whereas a structured process using a platform-independent model as a spec from which an implementation can be automatically created is a much more repeatable process. If you take the exact same xtUML model and the exact same translation rules, you'll get the exact same output. And this can have benefits in terms of code quality as well, and we'll talk about that next. A full xtUML process that leverages code generation can take advantage of structured, repeatable, built-in code quality. And this is because the translation capabilities from xtUML models to specific language implementations are done by model compilers that can be programmed to implement rules that have to be followed in the code generation. For example, C code can be generated that is MISRA-C compliant automatically. This is important because in a safety-critical program, safe coding rules must be documented, approved, and you have to have proof that they were adhered to. MISRA-C is a coding standard for C and also C++, developed by the Motor Industry Software Reliability Association. The purpose is to ensure that code for embedded systems is safe and reliable. MISRA-C is looked at in other safety-critical industries as well as a foundation of good coding practice for safe design. So any method that could assure compliance to MISRA-C supports these coding quality objectives. Now, some companies have gone a little beyond this. They've taken their own internal policies for coding to ensure safe coding styles. One of our BridgePoint customers, in fact, has formalized their rules into a customized model compiler, which links directly into the rule documentation where a detailed description exists. So they've combined the documentation of the rule with its enforcement. This is sort of like the requirements tracing process I talked about earlier in this flow, but in this case it's kind of a coding rule tracing, not requirements tracing. In this customer scenario, by default the model compiler will enforce all of the rules that are documented, but a user can annotate model elements with a motivation as to why certain rules should be excluded or overridden from the analysis. This annotation is read by the model compiler. So this is a very sophisticated method of leveraging automation along with enforcement of code quality. So this is a good point to probably stop and review what we've covered so far. Basically, we talked about how xtUML aids certain key aspects of safety-critical development. We first took a look at how a conceptual model was a much more thorough approach than manual review for requirements validation. Next, we looked at how requirements could be traced to the xtUML model throughout a model-driven development process. Then we looked at how an xtUML approach provides an enhanced verification environment to support the goals of testing early, testing often, and testing in the system integration context. I mentioned how an xtUML-based tool can automatically generate design documentation for internal reviews as well as external audits. I talked about repeatability, and also I mentioned this sort of approach could automate and enforce high-quality coding implementation. But this is all part of a methodology that relies on automation from tools. So you're probably asking yourself, what about tool qualification, right? Ah yes, tool qualification. Those very words, is your tool qualified, can strike fear and loathing from both tool users and tool vendors alike. But really the question shouldn't be, is your tool qualified, but rather, have you done what you need to do to eliminate tool-related risk in your process? What lots of folks don't realize is that all tools don't need to be qualified. In fact, most don't. So it's really important to understand what we mean by qualified and to understand some of the other terminology used in this context. Tool assessment refers to the process of determining if tool qualification is necessary. It asks the questions, does the tool use pose risk to the end product? Are these risks mitigated by process checks and balances? Now, tool qualification may result if the answer to the first question is yes and the last question is no. So tool qualification may vary in requirements based on what standard you're talking about, what industry, and even your certification authority, but typically involves verifying that the tool is performing its requirements. Now this could involve an extensive tool testing process, and it could also involve requiring the tool vendor to actually follow a pretty rigorous development process in the development of the tool itself. So let's look at the xtUML process that I talked about in this presentation in the context of these tool assessment and qualification criteria. So first, remember, manually created code is always subject to review and verification. So this is sort of the baseline standard. What this means is that in an xtUML process, if you're using the full edit, execute, translate flow, you should be treating your code very much the same as a manually created code. The first thing you might want to do is do a very thorough manual review of your test bench models. Make sure that those are correct, that they're testing the things that you really want to test. And then use these test bench models to verify the code that you generate. So this is your checks and balances in your flow. You're verifying the code that you generated. And then you probably want to supplement this verification with some amount of manual code review for the application models themselves. And when I say some, this amount can really vary depending on the criticality level of the application, along with the demands placed by the certification authority. The good news is that unlike some code generators, BridgePoint's translation capabilities produce code that is both very efficient and also very easy to read and understand. So I know some people have a fear that code generators produce code that is, like reading machine code or something, but the BridgePoint code is very efficient and very easy to read. So that's it. You really should have no requirement to actually qualify the tool if you follow this process. And the key is really just documenting this process, the tool assessment or tool, whatever the terminology you have to follow, the tool assessment process, let's call it. And then you have to follow that documented process, and then you have to document that you followed the process. And of course, you want to include this information in the appropriate places in your certification audit documentation. Okay, before we wrap up this session, I want to give you a brief glimpse at some real customer usage in both mission and safety critical domain. In the next few slides, I'm going to pull from a presentation that Saab gave previously on their use and benefits of following an xtUML process in their development programs. So Saab delivered this presentation at the Integrated Electrical Systems Forum in Seattle back in 2009. The title of their presentation was A Model-Driven Architecture and xtUML in Practice. And in this presentation, a software systems architect talked about their methodology and the benefits it brought to the Saab group. As part of this presentation, Saab discussed their flow, including their use of model compilers, of which they use both commercial and customized versions from our BridgePoint offering. But a key thing they mentioned was that this method and the use of the model compilers was suitable for both high performance and also safety critical systems. Saab concluded their presentation with the compelling business reasons for this choice of methodology. Even in the context of safety and mission critical development requirements, they saw rapid development of prototypes, reuse benefits from capturing corporate knowledge and speeding implementation variants, and finally that this approach integrated the systems and the software engineering disciplines in some significant and beneficial ways. So with that, I'd better wrap this presentation up. Complexity and certification requirements are driving companies to find new and improved development processes that are more supportive of both productivity and certification compliance objectives. An xtUML method is a modern approach for productivity improvements that has many features that are useful to ease the certification compliance burden. In terms of productivity gains, xtUML offers higher abstraction and higher productivity, effective reuse, and automation. And in terms of certification compliance support, xtUML offers conceptual model demonstration as a much better way for requirements validation, a mechanism to connect xtUML modeling to requirements in support of requirements tracing, an enhanced verification environment supporting early and frequent testing, including system integration testing, an automated implementation that's repeatable, supports the generation of quality code, and produces design documentation. And we took a brief look at a presentation from a Mil-Aero systems design company who talked about their usage of xtUML in a model-driven development context and the productivity benefits they got from this method, even in the context of their mission and safety-critical programs. Thank you for attending today's presentation, and if you haven't already, please visit xtUML.org. Thank you.